Mr. Rector, ladies and gentlemen, nutritional science is a young and complex scientific discipline. As an appetizer to this farewell address, I would like to take you on a short historical journey of this fascinating field where much is still to be discovered. Gerrit Jan Mulder, professor of medicine and chemistry at Utrecht University, was the pioneer of nutrition in the Netherlands. In 1847 he published the book De Voeding in Nederland in verband tot den volksgeest, setting the first dietary guidelines for the Dutch population. Mulder argued that the poor should eat more protein-rich beans and peas and less potatoes, and the wealthy were advised to eat less meat and less fat. Mulder died in 1880, just 5 years before Van Gogh painted his famous Potato Eaters, a painting which gives a nice impression of the living standards in poor rural areas in those days. Around 1900, the vitamin revolution began. 13 vitamins were discovered, including vitamin D. The seniors here in the audience, and I'm pretty sure that I'm one of them now, will remember the bad-tasting cod liver oil preventing us from rickets, and also known as the English disease. Later, in 1952, at the first International Congress on Nutrition and Dietetics in Amsterdam, the American physiologist Ansel Keys put forward the fat cholesterol heart disease hypothesis. The role of fatty acids in our diet is still keeping us busy today. See on the right the Time magazine of last year. In the Western world, changes in lifestyle began to have a major health impact. The excess of calories combined with a sedentary lifestyle brought us the obesity epidemic. Here you see the obesity trends over the last 50 years in the US and the Netherlands. Since the 1980s, obesity has doubled in our country, and in America, 1 in 3 adults are now obese. Meanwhile, in developing countries, hunger rates increased. The last 10 years has seen a dramatic rise in the double burden of malnutrition, where over- and undernutrition coincide. From the 1970s onwards, nutritional epidemiology and dietary intervention studies provided insight into the health effects of total diets, foods, and nutrients, and the food industry started, albeit slowly, to reduce or remove less desirable components from their products. Technological developments also had a major impact. The Human Genome Project, the omics technology, and the recent mapping of the epigenome made it possible to study genetic susceptibility and gene expression in relation to diet. Personalized nutrition became the new buzzword. And now, big data is trending. The term refers to huge amounts of data from multiple levels that can be obtained for any individual. This includes information from electronic, dietary and medical records, sensors, scanners, and social media. Digital technology will definitely become a major driver of nutritional science and public health in the future. After this flashback, I will offer you a 3-course menu, of course, if you are in nutrition. Early life nutrition, midlife nutrition, and late life nutrition. In Wageningen, we cover diet in health and disease over the full life cycle. International nutrition and metabolic health are chosen as central themes, and we pursue a multidisciplinary approach at the level of the cell, the individual, and the population. Time doesn't allow for a complete overview, but I will give you a flavor of our work and some future perspectives. I start off with the topic of early life nutrition. This map shows the countries that account for 90% of the global burden of malnutrition. The causes are low intake of energy and proteins, and the so-called hidden hunger related to the big 5 problem nutrients being iron, vitamin A, iodine, zinc, and folic acid. Malnutrition is responsible for almost half of all death in children under 5 worldwide. It causes health problems such as anemia, blindness, and birth defects, and later in life we still see the consequences, such as reduced growth, also known as stunting, impaired mental development, and lower work productivity. Imagine, the death of 1 million children per year can be prevented if there would be full access to just 10 proven nutrition interventions. Since the start of our division in 1969, international nutrition, especially of mother and child, has been a focus area. We have built an extensive network in Africa and in Asia, and we aim at institutional capacity building through training of local people and research collaboration. It doesn't work. Our research goal is to provide scientific evidence that nutrition interventions do work. Strategies to fight against malnutrition are supplementation, fortification, biofortification, and dietary diversification. To illustrate our research approach, I will give an example on vitamin A. Worldwide coverage of vitamin A supplementation is quite good, but deficiency persists and additional food-based strategies are needed.
School dinners at this school include an unusual experiment. Scientists are looking at 2 varieties of cassava, a major source of carbohydrate in Africa. Researchers hope that adding micronutrients to local staple foodstuffs will help fight malnutrition. Yellow cassava is richer in vitamin A than the white variety, but there's less of it about. Scientists want to know if including yellow cassava in the diet regularly would improve the health of malnourished children. So researchers pitched in for some science-based cooking. Both types of cassava mash are then served to different groups of young volunteers. For some, it's their only proper meal of the day.
This cassava study is part of a multi-center EU project coordinated by our division, and 6 African partners are involved. White cassava is the food these children normally eat, and it is low in vitamin A. To increase the vitamin A intake, white cassava was biofortified. This was done by crossbreeding vitamin A-rich yellow cassava imported from South America to Africa with local crops, resulting in varieties with increased levels. In the 18 weeks trial with 360 Kenyan children shown in the video, the biofortified cassava significantly increased blood vitamin A levels, and you saw the kids really liked the yellow cassava. An important milestone for improving early life nutrition was the launching of the 1000 Days Initiative by Hillary Clinton 5 years ago in Washington. This partnership of governments as well as the public and private sector calls for action on the first 1000 days of life, when better nutrition can have a lifelong impact on a child's future. I will illustrate this with iron and brain development. Brain regions involved in cognitive and social emotional performance are highly susceptible to iron deficiency, especially from the last trimester of pregnancy until 2 years after birth. Animal studies suggest that insufficient iron during critical periods of brain development is difficult to remedy. This is also true for humans. In a trial among 6,000 pregnant women and 4,600 live births in rural Western China, one of my Chinese PhDs showed that children had significantly lower mental development at the age of 2 unless sufficient iron was provided during pregnancy. In line with earlier meta-analysis, the China trial confirmed that extra iron lowers infant mortality and improves several health outcomes such as birth weight, duration of gestation, and early preterm delivery. This example illustrates that the first 1,000 days of life make up a critical and crucial window of opportunity to combat malnutrition, not only for iron, but also for energy and other problem nutrients such as iodine and folic acid. A second window of opportunity is the pre-pregnancy period. Nutritional status, and it was said today at the symposium already, of adolescent girls in deprived areas requires much more attention, because first pregnancy under age 18 is highly prevalent. Adolescent girls are in rapid growth and stunting is very common. What they eat affects not only their health, but also the health of their kids and even their grandkids. These transgenerational effects refer to epigenetics. Epigenetics describes heritable but reversible changes in gene expression, mediated primarily by DNA methylation and histone modification. Our environment, from diet to smoking and pollution, can leave epigenetic marks on our DNA, silencing or activating genes. The study among rural Gambian women presented today by Professor Andrew Prentice nicely demonstrates that the mother's nutritional status at the time of conception can influence her child's epigenome, with likely lifelong implications. DNA methylation was higher in children conceived in the hungry season compared to the harvest season, which was in line with the maternal periconceptional status of methyl donor nutrients. The epigenome links nature and nurture. Epigenetic changes occur not just in pregnancy, but over the full lifespan. Unraveling the influence of diet will become a major future challenge for nutrition science. An alarming phenomenon in Asia and Africa is stunted obesity. It is the combination of early life undernutrition and subsequent overnutrition. This so-called double burden of malnutrition can lead to diabetes and other chronic diseases later in life. We need to understand the risk factors, including genetics and epigenetics, of these Western type of diseases, because they differ in etiology in a non-Western context. We heard that today from Professor Anna Larti very clearly. Our intervention strategies here in the Western world cannot simply be extrapolated to African or Asian populations. Several nutrition-specific strategies against malnutrition, such as breastfeeding and supplementation, are effective and necessary, but insufficient to completely solve the problem. Equally important are nutrition-sensitive measures, such as agriculture, clean water and sanitation, education and employment. Our biofortified cassava study is a good example of how agriculture can contribute to nutrition security. And being part of an agriculture-oriented university, our division has the unique capacity to study how food systems can promote nutrition and health. For this farewell address, I created a number of 1-minute animation videos. I wrote the scripts myself, and I found a designer from an internet platform who helped me to put it in an animation. The videos express my view on some societal issues related to nutrition. The first one is on international food and nutrition policy.
International Food and Nutrition Policy. The Sustainable Development Goals will simulate governments to frame their agendas to achieve food and nutrition security and promote sustainable agriculture. At present, global agri and food industry makes unhealthy foods cheaper and healthy, sustainable foods more expensive. A long-term industry strategy, placing consumer and environment at the heart, and healthy, will better help reaching the development goals. Governments also need to show the political will to secure a healthy and sustainable food supply by international trade, pricing, and other measures. And if self-regulation by industry fails, measures such as taxing junk foods, controlling portion sizes, and kids marketing are necessary. It's our world. Take care of it.
Now we move on to the main course, midlife nutrition. He does look very happy, I admit. A challenge for many at this stage in life is weight management. Almost a half of Dutch adults is overweight and 1 in 8 is obese. Diabetes, a direct consequence of obesity, is projected to increase worldwide by more than 75% in the next 20 years. And largest increases are expected in Asia and India as a result of the double burden of malnutrition. Obesity is a massive problem, with many efforts to eat less and exercise more. The major enemy is our environment, with an abundance of low-priced, energy-dense foods and drinks, tempting advertising, and sedentary living conditions. In the 2015 Lancet series on obesity, it was stated very clearly. Today's food environments exploit people's vulnerabilities, making it easier for them to eat unhealthy foods. Results from weight loss diets are disappointing. Losing 5% of initial body weight in the long run is what trials at best show, regardless, by the way, whether they emphasize proteins, fats, or carbohydrates. It's the calories that count. The good news is that losing some kilos may already have meaningful health benefits. Modern science and technology is in the era of personalized nutrition and big data. Integrating multi-level data from genotype to phenotype in the environment is truly a challenge, but it will help to better understand obesity and other nutrition problems. And if we understand better, we may intervene better. I will take our Wageningen belly fat project to illustrate this multi-level approach. But first, I would like to show you how my own body responded to a dietary change. 5 years ago, I exposed myself to a self-experiment, being my own guinea pig for 2 months in a well-designed trial. The first month, I adopted an unhealthy diet and transformed myself into a couch potato. The second month, I changed back to my usual healthy pattern, and at regular intervals, blood and 24-hour urine samples were collected, and a series of tests and scans were completed. Here, on the top, you see all the foods and beverages I consumed in one unhealthy and one healthy week. The unhealthy pattern was not extreme. I did not go on a McDonald's supersize me diet, but chose, on purpose, a pattern reflecting the habitual Dutch diet. During the healthy period, I followed the Dutch dietary and physical activity guidelines. At first glance, the diets look quite similar. Closer look, however, shows important differences. More calories, saturated and trans fat, salt and added sugar, and less fiber in the unhealthy months. As planned and calculated by our dietitian, I gained 2.5 kilos in 4 weeks. Most body parameters worsened. In the second healthy month, all indices, including body weight, returned to normal. And the conclusion? I had never expected such fast and dramatic changes. The findings, although it cannot be drawn any scientific conclusions, but the findings convinced me even more how important diet and physical activity are for your health. At first, metabolic changes may be more pronounced in overweight and obese subjects. This slide shows body scans of an obese and a normal weight person. To reach a BMI of 36.2, I would have to put on 40 kilograms, 40. During the development of obesity, excess fat, which accumulates in and around organs such as adipose tissue, liver and muscle, may negatively affect lipid and glucose metabolism. Here you see how it works. The stressed fat cells release signals attracting immune cells that infiltrate the adipose tissue, leading to chronic inflammation. This process may result in insulin resistance, eventually causing diabetes and other chronic diseases. This slide demonstrates the molecular pathways that are activated in obese fat tissue and lead to insulin resistance. I will not go into the complex interactions between the immune cell and the adipocyte. Our molecular nutrition group is very active in this exciting field of immunometabolism. These mechanistic insights will help us to prevent or treat inflammation and ultimately improve metabolic health. Our Wageningen belly fat project, which I mentioned earlier, aims to study the effect of weight loss on metabolic health. In a 12 weeks controlled trial, 110 overweight subjects with an average BMI of 31 were randomized into 3 groups. The first group followed a Western unhealthy diet with 30% caloric restriction. The second group, an optimized healthy diet with 30% caloric restriction, and the control group consumed their usual diet with no caloric restriction. The subjects lost in 12 weeks as much as 600 kilos. The mean weight loss in the intervention group were 6.3 and 8.4 kilos, and the usual diet group gained 0.8 kilograms. Very nice study, I would say. The primary outcome was the percentage liver fat quantified by proton magnetic resonance spectroscopy. It decreased dramatically and significantly between the control and both intervention groups. As shown in this slide, the health effects of weight loss in the belly fat project is studied by measuring a large set of indices. New sophisticated techniques allow us to collect even more data. For example, we could have looked whether weight loss leads to changes in hunger and satiety and reward activation in the brain. The neurobiology of eating behavior is an exciting field. In our division, we are using functional MRI to measure effects of taste and smell exposure. Brain responses may also have been linked to the gut hormones and the microbiome, to see how the gut talks to the brain. We can easily and locally sample gut content by swallowing the capsule shown left. We are using this device to study the impact of different diets on the microbiome. And indeed, microbiota is popular nowadays, but as a real nutritionist, I would argue that one should not forget that it's our diet that drives the gut microbiota. Dietary intake assessment will also benefit from new technologies. Our new location at the Helix provides facilities for serving meals to 100 study participants at a time. This way, dietary intake can be well controlled. In free living settings, however, self-reporting of dietary intake is sensitive to bias and may become the weakest link. To improve this, we are currently testing web-based tools, making use of smartphones and wearable devices, for instance, sensors near the ear and the throat, measuring chewing and swallowing. Ideally, we would like to measure real-time validated food intake. You see, there are many ways to collect large amounts of multiple-level data from an individual, like we did in the BellyFit project. Integration of the multi-level data in the BellyFit project requires sophisticated bioinformatics and statistical methods for highly dimensional data. The resulting mechanistic insights will make us better understand why, for instance, on the same caloric restriction, one person lost 8 kilograms, whereas another only 2. The research strategy in our BellyFit study was hypothesis-driven, which implies a concise research question and measuring possible intermediary steps in the causal pathway. Now, with big data, gigabytes of information become available, allowing a data-driven, hypothesis-generating approach. Information on real-time dietary and medical practices, lifestyle, social context, and omics, often collected by individuals themselves, opens up new possibilities. Big data, however, also means big error, both random and systematic. It enables us to identify a wealth of signals which should be confirmed in epidemiologically well-characterized populations and finally be tested in intervention studies. As we heard from Professor Norbert Stephan today, obesity may not be unhealthy for everyone. And future research, including big data, may identify who is at risk and under what conditions. More complete understanding will make nutrition research move from a one-size-fits-all group level to specific subgroups and ultimately to what's in it for me personal level. Many overweight people want to lose weight and are browsing the internet for the latest hypes. As an intermezzo, I will now show you my view on nutrition and the media.
Nutrition and the media. TV, newspapers, books, internet, and social media. Nutrition is everywhere. Diet gurus promise weight losses of 1 to 2 kilograms per week, making big money by clever marketing but misleading the public. Other so-called experts glamorize exotic superfoods and are bashing basic products such as bread and dairy. Nutrition is entertainment for TV talk shows. Editors are not interested in the facts. Science journalists are more responsible, providing context in their articles. Good to see that nutrition is hot, but be aware of journalists seeking for sensation. And for the consumer, rely on authorities and forget about the hypes. They come and go and only cost you money.
And now for the dessert, late life nutrition. This is Susanna Jones, the oldest verified person in the world. She lives in the US and is 116 years old. Her key to long life? Surround yourself with love and positive energy. And on her menu, bacon and eggs every morning for over a century. Not very healthy, but Miss Jones most probably has very strong genes. Genes account for about 1/3 of the variation in life expectancy. This is the programmed part of aging. In fact, our DNA is programmed so that we slowly degenerate. Most of the aging process, however, is driven by random damage due to chronic stresses such as inflammation and oxidative stress. Many lifestyle factors, including diet, contribute to this damage, which may occur in all body cells. As we age, our body's repair machinery can't keep up, and the damage accumulates, resulting in age-related diseases. So as we grow older, we gradually lose our physiological integrity, leading to loss of organ function, decreased quality of life, and higher risk of disease. In Wageningen, we have a rich history in research on diet and the prevention of cardiovascular disease, cancer, and osteoporotic fractures, all manifestation of the aging process. I will now go into cognitive decline and sarcopenia, topics taken up more recently by our group on nutrition in the elderly. An aging brain is vulnerable to cognitive decline. Mental processes, including memory, information processing speed, and decision-making may decrease with age. This process may finally lead to Alzheimer's disease, with 80% of the cases the most common form of dementia. With the aging population, dementia will increase in the coming years, so effective prevention strategies are important. Using results from meta-analysis, it has been estimated that about 30% of Alzheimer's disease cases could be attributable to low education and lifestyle risk factors such as smoking, physical inactivity, hypertension, and depression, providing prevention opportunities. Intervention studies on cognitive decline targeting several lifestyle factors were for a long time lacking. Recently, a large 2-year randomized trial in Finland showed that a combined program on healthy eating, exercise, brain training, and vascular risk monitoring was beneficial for cognitive function and dementia risk. In a number of trials in our division, we have looked into the effect of individual dietary components on cognition. Promising candidates such as omega-3 fatty acids and B vitamins showed mixed results. This may be related to the timing and duration of the intervention or the ability of cognitive tests to pick up subtle differences, or simply that these nutrients don't have any biological relevance. Scanning of specific brain regions may increase the accuracy to spot changes in cognitive function. At the University of Oxford, a 2-year trial with a high dose of B vitamins among 156 elderly with memory complaints showed a significant reduction of the loss of gray matter. Gray matter volume is specifically affected in Alzheimer's disease. However, in a similar study among 200 elderly, we could not confirm these findings. To understand to what extent individual nutrients matter in cognitive performance, functional MRI may be helpful in future studies. A performance task in the scanner before and after a long-term nutrition intervention may better show changes in neuronal activation in relevant brain regions. For example, with a before-after Stroop test, as you can see these colors, we could study the effect on brain connectivity of long-term omega-3 fatty acid supplementation. Brain connectivity clarifies how neurons and neural networks process information. Use it or lose it not only holds for the brain, but also for other organs, like your muscles. This brings me to sarcopenia, which is the aging loss of muscle mass and strength. This slide showed a cross-section of the upper leg of a 25-year-old man and an untrained 33-year-old man. The gray matter is muscle protein, the white area is fat. With aging, you are losing muscle. Physical activity stimulates muscle protein synthesis, but dietary protein is necessary for a positive balance. Elderly people, however, are less sensitive for dietary protein to increase muscle mass. This is called the anabolic resistance. So an inactive lifestyle combined with anabolic resistance may lead to substantial loss of muscle mass up to 50% over the years. And sarcopenia is dangerous because it's associated with negative health outcomes such as falls, disability, and premature death. To prevent or counteract loss of muscle mass, resistance exercise training is particularly important since it stimulates the synthesis of type 2 muscle fibers, which are most relevant for muscle strength. Besides proteins, vitamin D and omega-3 fatty acids are other promising dietary factors to prevent sarcopenia. A study at our division among 60 frail elderly people showed that resistance type exercise training is an effective strategy to improve strength and physical performance. And indeed, additional protein was needed at breakfast and lunch to overcome the anabolic resistance to food intake, resulting in an increase in muscle mass in the protein supplementation group only. In a disease state and after acute inactivity, loss of muscle mass and performance is much more rapid and severe. A hospitalized patient, for example, may lose 1 kilo of muscle mass in only 7 days. In Dutch hospitals and care institutions, the prevalence of undernutrition due to protein and energy deficiency ranges between 20 and 30%. This is unacceptable. It raises healthcare costs due to the clinical complications and longer hospital stay. We could show that undernourished patients receiving protein-enriched foods improved strength and physical performance. Bread, juices, and desserts with extra protein were provided in the hospital and at home after discharge for a period of 6 months. It resulted in 20 to 30% higher daily protein intake and also a better muscle strength. The Cater with Care project is one of several spin-offs of the Nutritional Alliance Gelderse Vallei. 8 years ago, this unique collaboration between the General Hospital in Ede and our division started. Our joint goal is to achieve health benefits for patients by optimizing diet and physical activity before, during, and after medical treatment. The hospital developed into the first nutrition hospital in the Netherlands and Europe with an on-demand meal service at your request. And through this alliance, medical specialists, our academic staff, master and doctoral students are collaborating in many projects. To conclude, diet and physical activity are crucial for healthy aging, and you are never too late to change. For example, if you start at age 60, you will gain an extra 2 quality years on top of your life expectancy. Now I will show you the final animation video, and it's a topic at my heart on public-private partnership.
Public-private partnerships. The Cater with Care project is an example of public-private partnerships, bringing health benefits to undernourished patients and commercial benefits to food companies. We definitely need research collaboration with the agri-food industry to solve major societal problems such as hunger and obesity. Current science policy, however, is focusing too much on matching public research funds with industry money. This way, the industry increasingly determines the research agenda with the risk of solely addressing short-term business-focused topics. A better balance between curiosity-driven research and pre-competitive research with industry involvement is required. In the long run, this will pay off in terms of economy and public health.
I come to the last part of my talk. A few remarks on nutrition training should not be missing from this farewell lecture. Our bachelor-master program is the only full academic training in human nutrition in the Netherlands. The curriculum is quite flexible as students compile to a great extent their own study profile out of a broad range of courses and practicals. After the first graduates in the early 1970s, almost 3,000 students received their diploma. The last decade we have seen a sharp increase in student applications. To keep up the high standard of education, we had to introduce numerous fixtures for bachelor students last year, so a gradual growth for the coming years. In 1972, I started my Wageningen nutrition training. We were the generation of eternal students. In the education system nowadays, efficiency thinking is the norm. It's crucial, however, that students have sufficient time for personal development to be prepared for their societal role. In the 70s, I was active in political theater. We challenged, and I still like to do that, food multinationals in a play entitled The Dessert with the Bad Aftertaste, and had heated discussions with the audience. But appropriate in the 70s, we also experienced self-made space cake in the Wageningen Arboretum Garden, listening to Lou Reed and the Velvet Underground. In those days, we were trained as all-round nutritionists, with strong emphasis on research methodology and explicit connection to food. Nowadays, far-reaching specialization is inevitable, but research methodology and general knowledge of nutrition and food remains essential, making the curriculum very well unique and very well placed in Wageningen. Nutrition and health are now very much global themes, and societal and scientific developments continuously demand new and advanced education. For the near future, I see epigenetics, big data, and sustainability as essential topics for human nutrition training. Also, the mode of delivering education is rapidly changing, with e-learning and flipped teaching, where the traditional lectures are delivered online and reflection and discussion with students take place face-to-face in class. And the current information revolution requires training in so-called information literacy skills. Students need to recognize when information is needed and how to find, evaluate, and use it effectively. I was very privileged to have met so many interesting people in my career, and I'm very pleased to see many here today. I look back with satisfaction and harbor many good memories. First, working at the Netherlands Heart Foundation in the days when egg yolk was seen as a poison and was best given to your dog or used as a shampoo. But the egg made a comeback. And according to the latest US dietary guidelines, people don't need to worry too much about cholesterol in their diet. Later, I moved to the Erasmus University Medical Center and TNO. While the hot topic at that time was lipids, I kept myself busy with antioxidants and free radicals. This was a very new topic in nutrition research, and I was seriously asked by some well-respected colleagues, I don't say that they are here in the audience, if I had started a new political party. There were also moments when I volunteered myself for research purposes. This, by the way, not my buttocks, but comes close. To convince an EU committee that a fat biopsy taken from the buttocks is not painful, I volunteered in an instruction video. Years later, this video popped up in the US, and our students on excursion to the US embarrassed me by asking whether I had become an adult movie star. I will remember the students and faculty in the many teaching courses here and abroad. It's extremely rewarding to work with young people, and I loved the intriguing cultures and amazing landscapes in, for example, Africa, Asia, and China. I'm very grateful to all my Wageningen human nutrition colleagues. I have very much appreciated the spirit, the collaboration, and the good humor, which has resulted in excellent research and inspired teaching over the years. The move to the beautiful new Helix building will further stimulate creativity and productivity. I wish the entire team all the best, especially the two new shareholders, Professors Ellen Kampman and Edith Veskens, and the new chair of division, Professor Kees de Graaf. Sincere thanks is expressed to the executive board of Wageningen University for the trust in me over the near 25 years of my professorship. I'm proud of this university, addressing very relevant societal topics. I witnessed and was active in the strategic transformation from agriculture to life sciences. You see how it started in '72, then later, and now. And now there is emphasis on healthy and safe foods, natural resources, and the living environment. I've loved working in science, but also in administrative positions as Dean of Science and member of the academic board. And yes, managers could drive me crazy every now and then. And I'm pretty sure that this was vice versa. But constructive criticism has always been my main intention. For the guidance in my scientific career, I owe thanks to many, but two people deserve special consideration: Professor Jo Houtvast and Professor Walter Willett. During my one-year master training in epidemiology at Harvard University in 1983, Walter Willett was my tutor. We kept in contact over the years, and several of our PhD students went to Boston for training and research. And I was very proud, I can tell you, to act as a honorary promoter when you, Walter, were awarded a honorary doctorate by our university in 2003, standing quite close to the Queen. Huh? Walter, you are an exceptional scientist, and I admire your integrity, modesty, and friendly character. Thank you very much for your support. Professor Houtvast, dear Joe, you are a close friend and really like a second father for me. Over 40 years, you have been my teacher, supervisor, and mentor, asking me to become your successor 18 years ago. Your wisdom, inspiration, and social abilities are outstanding and served for me as a role model. I'm privileged to have met you, and thank you for your confidence and belief in me. We are both delighted to see that human nutrition in Wageningen is alive and kicking. The final words are for Anne Roos and our children Francine and Chris. Thank you for always supporting me to spread my wings. We have a great family, and I'm eager to go on a next journey in my life, especially as a very fresh grandfather. Ladies and gentlemen, thank you for your attention. Ik heb gezegd.